Tina. Hello and welcome to today's webinar, the NFPA 350 Guide for Safe Confined Space Entry and Work. I'm Ed Rakowski, Editor-in-Chief of The Synergist, a magazine of the American Industrial Hygiene Association. I'd like to thank all listeners for attending today's event, and especially the National Fire Protection Association for sponsoring this webinar. Founded in 1896, NFPA is a global nonprofit organization devoted to eliminating death, injury, property, and economic loss due to fire, electrical, and related hazards. The association delivers information and knowledge through more than 300 consensus codes and standards, research, training, education, outreach, and advocacy, and by partnering with others who share an interest in furthering the NFPA mission. Our presenter today is Nancy Pierce. Nancy is a certified industrial hygienist and a senior fire protection engineer with NFPA. She is the staff liaison for 9 NFPA technical committees, including the committee responsible for the development of the new NFPA 350 Guide for Confined Space Entry and Work. Prior to working for NFPA, Nancy worked for the Massachusetts Department of Labor, where she was an OSHA consultant for 10 years, and then supervisor of a public sector employee health and safety program for 12 years. There she developed a written model confined space procedure and policy for public sector workplaces and designed and presented full-day confined space training programs for public sector water and wastewater employees. Nancy has served as adjunct faculty at Northeastern University and Massachusetts Maritime Academy, teaching classes in workplace health and safety. She is currently the vice chair of AIHA's Confined Spaces Committee and recently published an article on confined spaces in the October issue of The Synergist. Now I'll turn the presentation over to Nancy.
Well, good morning, everyone. I'd like to welcome everyone to the webinar today, and this is a topic that is near and dear to my heart. And based on the number of people that have signed up for this webinar, I think there is a lot of interest in confined space safety. So I appreciate you all joining us. So before we begin, I just want to review some of the objectives for today's training. What I'm going to do is explain the background and vision for the new NFPA 350 document. I'm going to highlight some of the ways that this document addresses confusion and gaps in existing standards, explain how you can provide input into the document, and show you how to access NFPA 350. So I'd like to start by asking, have we solved the confined space entry problem? I think most would agree that the answer to this is clearly no. And whenever I do a confined space training, I usually challenge myself to see if I can find another confined space fatality that just happened recently by going on the web. And unfortunately, it's really never much of a challenge, since there's usually always something that I can find right away. So I think we still have a long way to go to solve the confined space problem. So when I did this in preparation for the webinar today, unfortunately I found one right away, and it happened a week ago Monday. There was an employee who went inside a transformer and became unresponsive. And shortly after that, another employee went in, and he also became unresponsive. And then a third employee followed and also became unresponsive. 2 out of the 3 have died. 1 is still listed in critical condition in an intensive care unit. And this is, often I think we think of confined space fatalities occurring in companies that really have no safety program or small businesses. Coincidentally, this company had just been awarded the North Carolina Department of Labor Silver Safety Award in May for the 2nd year in a row. So this type of fatality occurs not only at small companies who have no confined space awareness, but it can also occur at larger companies where I have to believe that this was a known hazard. And as you know, there's lots of different confined spaces and lots of reasons why people die in confined spaces, lots of hazards. And what's surprising to me is that so many of these spaces are well recognized as confined spaces. For example, tanks in breweries and wineries, and manure pits where fatalities just occur over and over again. And you'll see some of these highlighted over the past few years. The Modelo Brewery accident where 7 people died. There's been a number in manure pits. There's one up in the right-hand corner of your screen where there were 3 family members that died from a family farm in a manure pit. So let's talk a little bit about the numbers. Well, in the past, statistics show that about 2/3 of the fatalities in confined spaces were the result of hazardous atmosphere. And it is difficult to find data on confined space fatality. It appears that actually between the years of 2005 and 2009, that more people actually died during that period of time from safety-related hazards. So, you know, it's not just the hazardous atmospheres. It is, in fact, in some years it appears almost equally an issue with safety hazards as well. And one example of this is in 2010, 26 workers were killed in grain engulfments. And according to researchers at Purdue University, there have been more than 900 cases of grain engulfment reported, and with a fatality rate of 62% over the past 50 years. So this has been a hazard that has been well recognized for 50 years, and yet it continues to occur. So confined space fatalities in the same types of spaces in the same industries occur over and over again. And again, some examples of these that are most common are things like your agriculture, brewery, wine tanks. Those are sort of predictable confined spaces. All right, so many may wonder how NFPA got into this confined space arena. Well, NFPA has a long history of established standards related to confined space entry. One of the ones that is most widely recognized is NFPA 306. And since 1922, NFPA 306, which is Standard for Control of Gas Hazards on Vessels, has been around. And that is the origin of the Marine Chemist Program. And for those of you who are not familiar with what a marine chemist is, I think of it almost like a CIH who specializes really in the maritime industry and in particular in confined space entry and hot work in that industry. Those are the folks who certify tanks and ships and barges as safe for entry or hot work. And they have a very vigorous training program with testing for competency. So that NFPA has been addressing that since 1922 and has had a lot of success in the maritime industry with preventing fatalities. We also have several other documents, NFPA 326, which is safeguarding of tanks and containers for entry, cleaning, or repair. And we also get into the confined space rescue area with standards such as NFPA 1670, which is operations and training for technical search and rescue incidents. And we also have NFPA 1006, which is the rescue technician professional qualifications. So we've got many years of experience in confined space entry and in things like hot work and rescue. And looking at the success of the Marine Chemist Program at preventing injuries and deaths, the Standards Council at NFPA approved the formation of a new committee with a new project to be developed on confined space entry. So we had our first meeting of the committee in September of 2012, and NFPA committees are comprised of up to 30 individuals from a variety of interest groups such as manufacturers, special experts, enforcers, labor representatives, document users, and insurers. And this group of individuals came together for the first time in Philadelphia to work on the preliminary draft of the document. And some of you may have heard me talk about this before, but I get kind of sappy when I talk about confined space entry. It's a topic I'm very passionate about, and so we met in Philadelphia because I said that's the birthplace of all important documents, and hopefully this will be one of those that may have some real positive impact on worker safety and confined space entry. So we met and then we had 2 additional meetings after that September meeting, and we developed a draft document. That draft document was approved by the Standards Council, and it went out for public input. So at that point, it was out there for the public to review and make comments on. We did receive quite a few comments on that. We went back and looked at all of those, and the committee has to actually look at each individual comment that was received, and they make a change to the document if they feel that there was something valid that was brought up, a concern. That document then becomes the first draft of the document, and that document went back out again for comment, and then additional comments are received. The committee goes back again, looks at those comments, and then finally comes up with what we have today, which is the final edition, the first edition of NFPA 350. So you can see that there are multiple times that the committee actually meets, reviews what the public provides them for inputs and comments, and comes back to develop a draft. And we'll talk more at the end about how this process will continue and how you can submit additional comments to the document. All right, so now that you have some background on 350 development, let's look at our baseline in the U.S. of where we're at with confined space regulations. So I want to note here that while the committee recognizes that there are many other standards and regulations for confined space used in other countries, that for at least this first edition of NFPA 350, we used the United States standards as a starting point. So there's 3 key standards that could be used in the U.S. for confined space entry. The first, ANSI, Z117.1, ASSE Z117.1, provides minimum safety requirements for entering, exiting, and working in confined spaces. This consensus standard was developed in 1977 and predated OSHA's permit-required confined space standard by more than 15 years. However, in 1993, OSHA's permit-required confined space standard, which is 1910.146, became effective, and that is probably the most widely used standard in the U.S. today. However, it did not apply to places like construction. So we now have, and this was just recently released, it actually became fully effective this past fall. We now have a confined space and construction standard, which is 1926.1200 through 1926.1213. Sometimes you'll hear it called Subpart AA. That is actually very similar to OSHA's permit-required confined space standard, but it does apply to the construction industry. And I want you to take note of what is common to all 3 of these documents. You'll see in italics, it's the word minimum. These are all 3 standards that provide minimums. And they're actually all performance standards which tell you what to do but not how to do it. Okay, there we go. So as a basis for what the committee was looking at, we started off with the OSHA 1910.146 standard, which again is a performance-based standard. These are some of the items that are covered by the permit-required confined space standard, but again, it tells you what you need to do. For example, train your employees, develop written programs, identify your spaces, test your atmosphere, ventilate, etc., but it does not tell you how to do it. So what are some of the problems that we see with performance-based standards? Well, performance-based standards focus on a desired outcome. It tells you what to do and not how to do it. And while ultimately what we all want is just a safe confined space entry, it's sometimes difficult to know how to get there. And I like to use this example of a performance standard that some of you out there who have had children will really appreciate. If my goal was to have my kids clean up their room, and I simply told them to clean up their rooms, my son would probably pick up his toys and clothes and never vacuum or dust, whereas my daughter would likely vacuum and dust and leave her clothes and toys all over the floor. And neither one of them would probably make their beds. So what each of them may think they have done what was asked, the desired outcome of what I personally consider a clean room would not be achieved in either case. What I probably would need to do is to tell them how to clean up their rooms by providing a more prescriptive requirement, saying that I wanted them to pick up their clothes, their toys, dust, vacuum, and make their beds in order to achieve the goal that I wanted. So there seems to be a little bit of a balance between allowing some freedom for interpreting what needs to be done and providing guidance on how to achieve the desired outcome. So OSHA's permit required confined space tells you that you need to do all these different things like identify the hazards and determine acceptable entry conditions, but they don't tell you how to do that. And certainly in the case of, the performance standard being a clean bedroom, it's not so critical, but when you come to a confined space entry, we certainly do not want to leave a lot of that open to interpretation. So what is NFPA 350? Well, first of all, it's a guide. It is not a standard. It uses the words should versus shall. And the goal is to provide information to protect workers who enter confined spaces in all industries. So the goal that the committee had with this was that it would apply to all confined spaces regardless of industry. So that means we would want this to apply to construction as well as general industry, as well as any other type of confined space entry that would occur. So it's designed to supplement existing regulations, standards, and work practices by providing additional guidance. And the goal is really to achieve a higher level of safety with best practices for identifying, evaluating, eliminating, controlling, or mitigating hazards. The other thing NFPA 350 does is it provides cross-references to related confined space documents where appropriate throughout the document. So for example, a number of other ASSE and API, American Petroleum Institute standards are referenced throughout the document where appropriate. So when the committee first met in that September of 2012, they discussed the basic premise of the document that they were about to develop. And some of the ground rules established early on by the committee included that whatever we came up with, whatever the committee came up with, they did not want to conflict with OSHA. And that, of course, made sense. So they wanted to be at least as strict as OSHA's permit-required confined space standard and in no way conflict with that. And again, that's because this document is designed to supplement that information and not to replace the existing standard. So the committee also wanted to eliminate some of the confusion that they found surrounding the terminology used in the confined space standards, and they wanted to address gaps and provide guidance beyond the minimums. So this is just a brief summary of the scope of the document that kind of reiterates some of these goals that they had. And this is the table of contents. NFPA 350 has 16 chapters, and these chapters are designed to be used kind of comprehensively together, or you could use them sort of as a standalone chapter. So you can form a comprehensive program and look at all aspects that are in the document, or for example, if you wanted to improve your atmospheric monitoring program, you may want to just use Chapter 7 of NFPA 350 to start out with that. If you're designing a new facility, you may want to just look at Chapter 16 for guidance on prevention through design. And ultimately, and we hope so, you would decide to use the entire document to supplement your existing program. But it is set up so that you can kind of incrementally go through this to kind of kick your confined space program up a notch, so to speak. So first of all, the committee was very concerned, and this took a significant amount of time for the committee, with trying to address some issues that they saw as causing confusion. So when the committee met for the first time, they had had the benefit of having a 20-year history on what worked and did not work with OSHA's permit-required confined space standard. The first thing they did was to brainstorm to identify issues they felt should be addressed in the new guide. And the first issue they addressed was the confusion created by the terms confined space versus permit-required confined space. And then in addition, looked at the confusion caused by the different types of entries, reclassification versus alternate procedures, and how those could be different from permit-required confined space entries. They then looked at gaps that existed, primarily in the lack of consideration of things like adjacent hazards and how hazards were identified and controlled. They also looked at things like competencies and how that was handled. And they looked back at things like the Marine Chemist program, where competencies for things like gas monitoring provided some guidance. So here is one of the biggest issues I think that most would agree is confusing about OSHA's permit-required confined space standard. A space that's called a confined space one day becomes a permit-required confined space the next, as soon as you bring a chemical in or you go to weld in a space. In addition, a space that could be entered using reclassification one day needs to all of a sudden be entered using alternate procedures the next day when an atmospheric hazard is introduced. So I don't know about you, but for me, when this standard first came out 20 years ago, 20 plus years ago now, that was really the thing that I had the hardest time wrapping my head around, with some of the terminology. And then to make it even more difficult, trying to explain that difference in that terminology to the regulated community and to those that needed to enter confined spaces was always a challenge. So here's just an example of that. As you know, a confined space is only a permit-required confined space when it has a hazard. In 1910-146, OSHA's standard only addresses permit-required confined spaces, so only those spaces that have a hazard. And while that may sound reasonable to only be concerned with confined spaces that have hazards, here's the problem. If you look at something like this water pump vault, is it a confined space and not covered by OSHA's standard, or is it a permit-required confined space that is covered by OSHA's standard? And the answer is it depends. A space can be a confined space one time and a permit-required confined space the next. The same space is defined by different terms depending on what's being done in the space. And in this case, if a worker is simply entering for inspection to visually inspect for leaks and lines, this space would probably just be considered a confined space. However, if the worker has to enter the space to repair a line by welding, it would likely be considered a permit-required confined space. And there are very different requirements depending on what you call the space. And in fact, even for signage purposes, OSHA may not require you to label this space nor to identify it in your written program, because it's not inherently a permit-required confined space. So, after many hours of deliberation, and I think that we have our committee chair also listening in on this, and he's probably shaking his head right now. It was many hours of deliberation. The committee thought that they had come up with a method to solve the problem of confusion, and I think they've done a great job with this. The problem is we've got to sort of try to all now wrap our heads around this change in how we think about confined spaces. But I think this has really simplified the application of confined space standards. So the committee decided to only use the term confined space in 350. And the rationale was that all confined spaces have the potential to become permit-required confined spaces depending on what is being done in the space. Therefore, it's important that all confined spaces be evaluated for hazards each time an employee enters a confined space. Then, if a hazard is identified, control measures are determined and permits are issued if necessary. So, here's the difference. It's a confined space with a permit, not a permit-required confined space. And we'll see how this is applied in 350 in a few minutes. So to further complicate the issue, if a space is identified as a permit-required confined space, then OSHA allows for 3 different types of entry depending on the type of hazards that remain after control measures are applied. Alternate procedures entry allows a worker to enter a space without an attendant when the only hazard is an atmospheric hazard that can be controlled by ventilation and where periodic monitoring of the spaces occur. So there's our alternate procedures. Reclassification also allows a worker to enter a space without an attendant when all safety and health hazards have been totally eliminated. However, if any atmospheric or serious safety hazards remain in the space, then a full permit is required. Permit entries require an attendant and an entry supervisor who may or may not serve the role of an entry supervisor who signs the permit. Some form of rescue is then required. And this next slide shows a chart of the 3 types of entries that are allowed under OSHA's permit-required confined space standard. And all 3 types of entries require, if you notice in the right-hand column, some type of certification and signature. And many facilities actually use 3 different documents: an alternate procedures entry form, a reclassification entry form, and then a 3rd document for a permit. But in all cases, in order to determine which of the 3 entries is needed, you first have to determine if there are hazards, and then you need to determine if the hazards are controlled. So in the case of alternate procedures and reclassification, OSHA actually allows you to do this without going through any type of formal checklist. All you need to do is to have a certification with a signature saying that that determination has been made. But since all 3 types of entries require an evaluation of a hazard, NFPA 350 recommends using a pre-entry evaluation for all of these confined space entries. So all spaces are evaluated using one form called the pre-entry evaluation form. So what is a pre-entry evaluation form? Well, it's simply a checklist that helps you walk through the possible inherent, introduced, and adjacent hazards in a confined space, in or adjacent to a confined space, so that you can determine what is needed to enter the space. The requirement to evaluate these hazards already exists in 1910-146. It's just not always formally documented. So again, for alternate procedures and reclassification, you kind of have to do this all, but you could do it kind of in your head versus going through a formal checklist. What we found out was that there were many facilities who actually have confined space entry programs who figured out that it just makes sense to use a similar checklist to document the hazards of all confined spaces and to help determine if alternate procedures or reclassification procedures can be used or whether a permit is needed. Now, there is one additional thing that NFPA 350 has established for this pre-entry evaluation that you will not see in OSHA's permit-required confined space standard, and that is the recommendation that an additional step be that atmospheric testing be done prior to entry into all confined spaces to verify that a space is safe to enter. And I'll show you how all that works in a minute. So a key component of your pre-entry evaluation, where you're going through to determine your hazards and your controls and whether there are hazards that still exist in order to determine what types of procedures you need to enter, We also are recommending that you do atmospheric testing, and that's the default position, that you do an atmospheric test. And that was a big source of discussion and debate amongst the committee members, but ultimately the committee agreed that the few minutes that it takes to test a confined space atmosphere to ensure that it is safe is time well spent. And here's the analogy I like to use, is that you're going to assume the dog will bite. So when you have a confined space that you're trying to figure out whether or not it has a hazard and whether or not it's an alternate procedures reclassification or permit entry under OSHA, you're going to assume that you're going to want to test that confined space to make sure and verify that there is no hazard prior to entry. And I like this picture in particular because this looks like what would normally be an extremely friendly dog, but he does not look too happy in this case. So spaces that look pretty harmless, you really don't know until you test to verify. And I'm wondering, that case with the transformer, that may have been something very similar where the atmosphere may have been what was the cause there, and perhaps that is not something that is normally done. So a sample pre-entry evaluation form and permit are included in NFPA 350, and you can see the first part of the form, it's very small, but on the left-hand side, the parts 1 through 3 are your pre-entry evaluation. And if you go through that pre-entry evaluation and you find any hazards, you simply continue on into the permit form. But regardless of where you end up, you're going to end up with a signed certification, whether it's the pre-entry evaluation that you get to stop there because there are no other hazards, or whether you go into the permit and then end up with a form at the end that is signed a permit form. So to summarize, NFPA 350 provides a mechanism for using one term for all confined spaces, and to evaluate all confined spaces the same way, using a pre-entry evaluation and then following into a permit if necessary. The hazards or lack thereof are recorded along with applicable controls. This eliminates the need to be concerned with the terminology for different types of entry. So let's see how this would work in a flow chart in practice. So again, this is maybe a little bit small and hard to read, but I'll try to walk you through it. So we go through the normal questions that we would normally have, where we determine that it's a confined space in these first 3 questions. And then if it is a confined space at all, you have to then, and your question is answered yes, then you have to go to a pre-entry evaluation under NFPA 350. From that pre-entry evaluation, you're going to look first at a lot of the safety hazards to make a determination of whether or not those exist. And then following over to the left-hand side, you would then perform, even if there are no safety hazards, you would go perform atmospheric monitoring. So if your answer is no, you still go into performing atmospheric monitoring. Then you look to see whether or not the levels are outside of established parameters. If they are not, then you are going to end up with a reclassification. So we're over here, way over on the left. So now you have a reclassification space. So we don't use that term in NFPA 350, but this kind of walks you through where you would be in the equivalent for the OSHA permit required confined space standard. So you go through, you do your pre-entry evaluation, you find that there are no hazards whatsoever, you verify that there is no hazardous atmosphere, you end up with a reclassification space. Now your signed certification form that's required under 1910-146 is simply your pre-entry evaluation form. So there's your document for that. Now if we go along and we do find that there are no hazardous, no safety issues, but that we test the atmosphere and you do have a hazardous atmosphere, then you get into alternate procedures. So your only hazard in this case is your hazardous atmosphere, and under OSHA 1910-146, that's your alternate procedures. Now, some of you may be concerned because if you read what I just covered over with the red alternate procedures bubble, that said permit entry. All that means is that you've gone into the permit now because you've identified a hazard. And what are you going to list on that permit? Well, you're going to list your control measure, which is ventilation. So it takes you the same place as OSHA 1910-146 would take you. It just gets you into that permit form, which then again can become your signed alternate procedures form. And then finally, if we had a full permit required confined space entry, that is all the same. As soon as you have any kind of safety hazard, you get into a full permit entry, or if you have any hazardous atmospheres that you cannot control with ventilation. So you do end up in the same place ultimately. So that hopefully clears up some of the confusion. I will tell you that it'll probably take you a little while to kind of keep reading that to kind of understand how that works, because now for those of us that have worked in that other terminology for many years, it does start to get a little confusing. So hopefully once you read this a few times, you'll see that it really has simplified things, that we're just calling everything a confined space. So what about additional things that are covered by 350? Well, there were additional gaps. One of them had to do with atmospheric monitoring. And so NFPA 350 provides a lot of information on selection of the proper gas monitor, how to calibrate, how to do bump testing, etc. You will notice that there is a difference that's highlighted down here in the acceptable levels of entry for oxygen. And that is consistent with what we have in NFPA 306 for marine vessels and shipyards. And basically, it's providing an additional level of protection, because there really is nothing in nature that should increase your oxygen levels. So as soon as you get up to 22%, you should really stop and then look to see what is going on. We also talk about having a qualified gas tester, and that's the person who is going to be doing the monitoring. And we'll talk a little bit more about competencies later. Another gap that was identified was guidance on ventilation. Unfortunately, there's not a lot of hard science on ventilation of confined spaces, and there can be many ways to ventilate a confined space, but NFPA 350 starts to talk about how to select the right type of ventilation for a space, looking at things like the configuration and the hazard you're trying to control, looking at whether you're trying to ventilate to provide an increase in oxygen, removing flammable vapors, or removing contaminants. So we have some different diagrams in the document and some guidance on ventilation. And again, some of the things that are covered in the document, things like talking about the fact that ventilation is dependent on the type of atmosphere you're controlling. If you are using, if you have low-level contaminants, or if you have a low oxygen atmosphere, supply ventilation can be effective. However, there's definitely times when you would not want supply ventilation, such as when you could bring a level of flammables into the explosive range. The other time you would really be concerned with supplying ventilation is if you had highly toxic contaminants that may, if you supplied air to the space, what the air being displaced out, that highly toxic material could affect the attendant outside the space, could affect other people in the area, or it could have an environmental impact. So those are the kinds of situations where you would probably want to consider exhaust and scrubbing that exhaust. So we talk about some of those considerations. Another gap that was identified, and this was identified actually both by the Chemical Safety Board and by the committee, is adjacent spaces. So those are spaces next to the confined space, probably where people like the attendant are. And so that was one thing that was addressed in this document. And NFPA 350 provides clear guidance about 3 categories of hazard: inherent, so that's just something that is already existing in the space; introduced, which are things you're bringing into the space, such as a chemical for cleaning or a welding, something for welding; and adjacent hazards, which are outside the space but may impact the space. And so the pre-entry evaluation form actually identifies those 3 distinct types of hazards. And that just helps remind you that you're not just looking into a space and saying, oh, there's nothing there. Oh, I've tested the atmosphere and there's no problem. It makes you think about the fact that you're going to be introducing things into that space possibly, or that there may be hazards adjacent to the space that you need to consider prior to entry. And here's just a couple of quick examples of some adjacent space issues. There was a fatality with a person who was cleaning near the opening of a methylene chloride tank, and they believe that he fell into the tank first, probably being overcome by the methylene chloride. We also, probably most of you are familiar with the Valero case, where there was a nitrogen asphyxiation. And again, they believe that the person was outside the tank and was overcome by that material, by the nitrogen. And there's certainly been a lot of confined space incidents that have been noted by the Chemical Safety Board, where flammable atmospheres outside but adjacent to confined spaces led to explosions and impacted the confined space. One of the things NFPA 350 has done is to recommend that all inerted atmospheres be posted with the following notice, and that should eliminate any possibility of miscommunication. And the industrial hygienists that are out there clearly will appreciate that NFPA 350 talks about the hierarchy of controls for addressing hazards and looks at what are the most effective methods of controlling the hazards using the hierarchy of controls. And there are a lot of different pieces of information on how to control hazards in the document, and also looking at how to control hazards that are brought into the space, introduced into the space as well. Another big gap that was identified was on rescue, and that gap was that there are generally organizational elements in place for fire departments, but not necessarily for facility rescue programs. So we had some fabulous rescue experts on this committee, and they have made some great recommendations in this document. This document works with NFPA 1670 for the technical aspects of rescue as well. Also references job performance requirements that are covered in the Technical Rescue Professional Qualifications document, which is NFPA 1006. And they talk about rescue configurations and gear, and there's a focus on pre-incident planning and evaluation. So non-entry rescue is emphasized and is consistent with 1910-146. However, when rescue teams are required, NFPA 350 provides a tiered approach to response. And that response and that level of response is dependent on the hazards that remain after the controls are applied. So in some cases, the recommendation is to have a rescue team immediately on site. There's others where they have to be available, and others where they do not need to be on site at the time of the entry. So there's 3 tiers. And NFPA 350 recognized that demonstrated competencies are critical for those workers who are involved in confined space entry and work. So in addition to the entrant, attendant, and entry supervisor roles that are defined by OSHA, NFPA 350 provides recommended competencies for those who perform tasks such as atmospheric monitoring, ventilation, and rescue. Now, this does not mean that NFPA 350 recommends that you have all these additional workers assigned to perform those tasks. It's just that the person who is responsible for performing those tasks should be competent and qualified to do so. So, for example, the gas tester is defined in the document, and that person should be qualified beyond simply turning on the monitor and recording the results. This person should also understand how to calibrate and interpret atmospheric monitoring results. And likewise, an attendant who's responsible for ventilation of a space should understand the equipment and method required to maintain safe atmospheric conditions of the space. We also have a management of change form and a chapter on management of change. The committee recognized that changes in space configuration, equipment, materials, contents, or work tasks can significantly impact confined space entry. And so we provide a sample form in Annex that helps you identify and evaluate the potential effects that change may have on that confined space entry. Prevention through design, that's really the pinnacle of the hierarchy of controls. It's been found to be the most effective type of control and the most cost-effective safety control, since it eliminates the need for hazard controls by eliminating these hazards in the design stage. And the committee looked at how this could be applied to confined space entry. So there is a chapter on prevention through design, and there's lots of ways to eliminate the hazards or to minimize the hazards. So for example, if you don't want an employee to stick his head into a space, as is shown in that bottom right-hand slide, then make the hole the right size so that somebody cannot stick their head in that space. So there's ways to design and redesign. There's things like putting in anchorage points, putting in standard staircases, adding ventilation to a space. All those kind of things can be done in the design phase to eliminate some of the confined space hazards. What I've shown in the middle, there's San Francisco Public Utilities Commission has a whole book similar to ACGIH's Ventilation Design Manual, where they show templates for good design for confined space. And we expect that because this is really the first document that specifically addresses confined space prevention through design, that we will be adding some different documents to this, reference documents to this chapter. For example, there is right now a grain silo standard that's proposed to have a requirement for anchorage points. We would want to reference that. And I understand that there actually is another document in the works for manure pit design that incorporates safer design. So we want to become a repository for those pieces of information. The OSHA confined space standard for construction is something that we will be looking at. Again, as I mentioned earlier, it was, I think, the last day of our meeting for the second draft. So it was the last date that actually OSHA released this construction confined space standard. So a complete review of that document was not done by the committee. However, I have looked at that document, and I can tell you that most of the concepts appear to align very well with NFPA 350. The construction standard uses the term entry employer, and we use the term entrant employer. They're very similar. The confined space document has a competent person evaluating the spaces, which of course aligns very well with what we're recommending. And they also recommend continuous monitoring of confined spaces versus periodic monitoring that's required for the general industry standards. So the first cut, it certainly looks like that's going to align very well, but we will take a look at that again. So just to wrap up, I want you to know a little bit about the Codes and Standards development process. NFPA 350, the 2016 edition, is now available. It was just released last month. And because we go through an ANSI consensus standards process, we will be revising our document every 3 to 5 years, and probably will start out every 3 years with a new document to make sure that we keep looking at this document regularly to make sure we improve it and we're consistent. So the next document will be released probably about 3 years from now with a 2019 date, and we probably will have at least 3 in-person meetings between now and then. And all those committee meetings are open to the public. By about March of next year, you will actually be able to go onto our website. We'll be able to click on whatever section you want to propose a change to or add a new section, and you can submit that recommendation and provide a good solid substantiation or reason for that change. And then the committee will consider everything that it has received. And that document, again, then will be revised. That will be our first draft. And that will go out for a second round of review, and you can come back and submit comments to those changes. All NFPA documents can be accessed free of charge online at www.nfpa.org and then / whatever the standard number is. In this case, it's 350, so /350. You do not need to be an NFPA member, but you do need to set up an account with an email and password. So you can look at them free of charge, or you can purchase them in PDF or paper copy. This is what you will get when you go to the www.nfpa.org/350. This is what we call our document information page. There are different tabs. You would want to click on the current edition tab in order to purchase the standard, or it looks like you can actually click over here on the right. If you want to view it free of charge, you would click on the current edition and then sign in with your email and password. There's products and training. There's some training programs available. You can look up who's on the technical committee by clicking on the technical committee tab. And then the next edition tab will tell you where our meetings are. It will post the agendas, the meetings, the meeting location, and all of that. What I would recommend for people that are interested is to sign up for email alerts that I just have circled up here at the top of the page. And that if you sign up for email alerts, then whenever anything is posted to the NFPA 350 page, you will be notified by email. So when the document is open again for public input, you'll be notified. When we post a meeting agenda or anything like that, the minutes of the meeting, anytime the first draft is completed and posted, those will all be, you'll be notified of anything that is placed on that document information page. So it's a great way to kind of stay in touch. Okay, and with that, I'm a few minutes over, I think. We were hoping for 10 minutes for questions, but I'm happy to stay on. And my email is there as well. So I want to thank you for participating today.
Hey, thanks, Nancy. It looks like we have about 5 minutes for questions. We already had a few. If you have a question and we don't get to it, please go ahead and put it into the chat window anyway. And a transcript of the chat will be sent to Nancy. And obviously, she just put her email address in the chat window as well, so you could follow up with her directly. But the first question, Nancy, is from Jeremy, and he asks, why did NFPA leave out hazardous energy such as radio frequency, radiation, and laser?
Well, that's an excellent question. That actually is something that the committee has on the agenda for the next edition. I think that we looked at that. There's only so much time that we had to go through this. We actually, I think we may have had one public comment that came in at the second draft stage, and the committee just did not have time to really vet that. But we are definitely looking at that, and we would encourage you to submit any public inputs. We would also love to have you join us either at a meeting or through a task group to incorporate some of those changes. But that is an excellent question, and it is something that they're looking at.
Okay, here's a question from James. Has OSHA documented a position that compliance with NFPA 350 will also meet or exceed compliance with 1910.146?
No, they have not. And again, this document is to supplement what is required. So the idea is that you're using 1910.146 or the new construction standard as a base, and then you're using what is in 350 to tell you how to do all of that. I've definitely given many presentations where OSHA has been present. I have never been told that there's anything that they see in there that's a conflict. And in other words, if you use our terminology of confined space, then you go through the process of pre-entry evaluation. No one from OSHA has ever said there's going to be a conflict doing that. So I'm not sure we would ever be able to have OSHA come out and say that, but that's a great thought. We are going to try to work with them to see if we can get the link to 350 posted on their website as well.
Okay, this question just came in from Wayne. An alternative approach taken by many firms is to treat all confined spaces as permit required, and he asks for your comment.
So, calling it a permit required, I think it's very similar to what NFPA 350 has here. We're just still calling them confined spaces. They all are confined spaces. Alternate procedures, all that means is you've got a hazardous atmosphere. You don't have safety hazards. You've just got a hazardous atmosphere, and you can control it by ventilation. That gets you down to the same place. It's the same procedures and the same requirements, whether you're following through on an OSHA alternate procedures form or you're following through on 350. So I'm not sure that I'm answering the question the way that I'm answering exactly what the question is, but it should be exactly the same outcome, in other words, whether or not you're signing it on a permit form or you're signing it on an alternate procedures form. But I agree. I think most people, if you look at it, why is it not a permit? You've got a hazard and you've got a control measure. Why isn't it just documented on the permit? That's how 350 does it. You're just documenting it on the permit versus documenting it on an alternate procedures form.
Okay, I think we have time for just one more question if we can squeeze it in from George. He asks, how are copies of the forms in the standard available for downloading and use by companies?
If you purchase the document, the forms are available on the document. You cannot, if you're just looking at it free of charge, you would not be able to access those documents. Although we do make some of them available through, we have like an online training series, a 3-part series that's available, and I know we have made the permits and some of those other forms available as part of that for download specifically. So there's a 3-part hazard identification, recognition, evaluation, and control module. So it's recognition, evaluation, control. So if you're interested in that, in those online training series, they do have those available. Otherwise, it would be if you purchase the document. Otherwise, you can just view them.
Okay. Unfortunately, Nancy, we're out of time. I apologize to the audience if I wasn't able to get to your question, but as I mentioned, we will provide Nancy with a transcript of the chat, and she has provided her email address as well. You can please feel free to reach out to her specifically. My thanks to Nancy for her presentation, to NFPA for sponsoring today's webinar, and to all of our listeners today. I hope you're able to attend our next Synergist webinar, which will be next week, December 15th, on measurement of potential exposures to isocyanates. Thank you and have a great day.
Thank you.